Welcome to this session. In the last session, we were discussing about regression testing, and we saw that regression testing is an important type of testing, where we need to test the unchanged part of the software after each change. Typically, the change occurs to only few lines of code and few tens of thousands of line or hundreds of thousands of line of code does not change, but then we have to retest all those parts, unchanged parts, even though earlier they had passed. The reason is the dependency. A change may induce problems in the unchanged part because of the variable value propagation. Some value which is changed in the during change of the some few lines of code propagate through the software and surface as bugs in the unchanged part. And then we had seen that the set of test cases which were originally used to test the software, they can be partitioned into the obsolete or invalid test cases, which we need to discard. Then we have the redundant test cases, which we need not as well run, because they have zero chance of detecting a bug, because they test the features which are truly independent of the change. And then we have the regression test cases, which test those parts of the software which have some dependency with respect to the changed software. Now, let us see what are the different steps through which we select the regression test cases. So, the major regression testing tasks are the steps in selecting the regression tests. The first thing is to identify the valid test cases, because as we said that after every change some test cases become invalid, they need to be discarded. So, we have to first identify the valid test cases, and out of the valid test cases we need to identify and ignore the redundant test cases, and that leaves us with the regression test cases, and that is called as the regression test selection problem. And if the regression test cases are too many, thousands, then we might need to do minimization, where we remove test cases which do not really they are kind of duplicate and they do not really detect additional bugs. So, the minimized set of test cases is as good as running the entire regression tests. And we might also do regression test prioritization. Out of the regression test cases that have been selected, we might prioritize them into 1, 2, 3, 4, with the highest priority given to those regression tests which have the maximum probability of detecting errors. Why do we need to prioritize? We need to prioritize because if we can detect the regression bugs early during testing, then the development team can get started, and that will reduce our delivery time. We might have hundreds of regression test cases, and it may take a week to execute all of them, and if we can detect the bugs the very first day, we might get the development team started on the testing. So, that is the idea behind regression test prioritization. So, if we represent that in the form of a schematic diagram, we first do the change analysis, and based on the change analysis we find out which part of the code is impacted, which part of the unchanged code is impacted and which part is independent, and based on which part is the impacted code and the test cases which run or execute this impacted code, we make the regression test selection and then we run the regression tests and report and retest the results. Now, let us look at another important topic in testing, which is testing object oriented programs. We had said earlier that object oriented programs were introduced with the assumption that if we have very good programming practices inculcated, then the chances of bugs will be less. For example, inheritance, encapsulation and so on, the different features of object oriented programming, they are known to be very sound programming concepts and they potentially reduce the chances of bug, reuse existing code, reduce development effort, and at the same time they are also expected to reduce the chances of bug. But we will be surprised to learn now that they actually complicate the testing. They introduced new types of bug which were not aware in procedural code, and therefore, we need different testing for object oriented code. We cannot just use the same techniques we used for procedural programming in object oriented code. We need different testing strategies. Let us look at that. But before that, let us have a small quiz on regression testing, which we just discussed. So, the question is that is regression testing applicable at unit integration or system testing? Is regression testing applicable to unit testing, integration testing or system testing? The answer is that actually it is applicable to all these three levels of testing: unit testing, integration testing and system testing. Actually, regression testing is a different dimension of testing, and therefore, we cannot say that regression testing belongs to only one level of testing. So, level is one dimension and regression testing is a different dimension of testing, and it is applicable to all levels of testing. Now, let us look at testing. How do we go about testing object oriented software? If we look at the data that is made, research data that is made available, a typical organization, development organization spends 50% of its effort on testing, the rest 50% on specification, design, coding, etc. And the main reason behind spending such huge effort on testing is that the quality of the software depends to a large extent on the thoroughness of testing. And now, the customers are very quality conscious. So, if an organization releases software full of bugs, then not only the customers will reject that product, but also they will not buy products from that organization. So, every organization spends significant effort on testing, and in that context the object orientation was a welcome change. When object orientation was proposed in the initial years, everybody expected that it will substantially reduce the testing effort. The 50% effort that is being spent may be reduced to 20-30%. That was the expectation. But then, as we shall find out now, that object orientation actually complicates testing and may need more effort rather than reducing the effort. Let us look at what are the challenges of testing object oriented programs, which did not exist in procedural programs. So, here we have new problems, new types of faults, and therefore, very difficult challenges in testing object oriented programs, which did not exist in procedural program testing. The first challenge is that what is the unit of testing? If you remember the context of procedural programs, we had said that a unit is either a function or a module. So, the idea is that in procedural programs we test the units, and as long as the units have been thoroughly tested, we then concentrate on integration testing, removing the interface errors through the integration testing, and then we do the system testing. But if you look at the analogy of a procedure and a object program, you might think that if unit is a function in procedural program, a unit of testing in object oriented programs may be a method, because methods are analogous to functions, but as you will find out, no, it is not correct. The other thing is that the good features of object orientation, encapsulation, inheritance, polymorphism, dynamic binding, will investigate, do they help in testing, do they reduce the effort in testing, or do they make it more complicated and need to spend more effort in testing. Let us investigate that issue, and then let us examine the new type of testing here needed, state based testing, and then let us look at what is the notion of test coverage analysis in the context of object oriented programming, and also the integration strategies. The integration strategies that we had discussed in context of procedural programming, top down, bottom up, and so on, is not really very appropriate here, because these are not really hierarchical designs, layered designs, these are only the objects interacting with each other. So, we need different integration strategies. So, first let us address this very fundamental question: what is a suitable unit of testing for object oriented programs? Because this is the foundation of any testing, that we need to do first the unit level testing. So, which units or which elements of the software we need to test independently and then do the integration testing. In the conventional procedural programs, the unit is a function, but as we will see just now that method is not really the basic unit of testing for object oriented programs. So, the analogy, if we extend a function to method to be unit of testing in object oriented program, is not really correct. We will see what is the basis of making this claim. Actually, the basis of making this claim is attributed to the Weyukar's anti-composition axiom, which says any amount of testing of individual methods cannot ensure that a class has been satisfactorily tested. Let us see what it really means. So, that is Weyukar. Actually, the suitable unit for object oriented programs is class. We need to test all classes in isolation and then finally integrate those classes. So, why is class a good unit of testing and testing the methods and then integrating will not work? So, the answer to that is that if we just simply test the methods, then we are not doing several things correctly. One thing is that we have these class attributes which are shared between various methods. We are not testing those just by testing the methods, and also the classes typically have state models. Since they store data, every class stores data, the classes show significant state models. That means that a class or an object can exist in a number of states, and if we test a method in one of the state, it may be working correctly in one state, but it may not be working when the class is in some other state. So, we need to consider the state model of the class and have the object assume different states, and then we need to test the methods there. So, not only that, we have to test the method interactions through class variables, but also we need to test the states, the methods at different states of the class. So, the Oyukar's anti-composition axiom, which is a landmark result in this area, appeared in IEEE Transactions on Software Engineering in way back in 1986. The statement of his axiom is that adequate testing of individual program components does not necessarily suffice adequate test of entire program. So, he says that if you just test the individual components, that does not really guarantee that the entire program will be working. If P and Q are components, P has opportunity to modify the context seen by Q in a more complex way than that could be done by stubs during testing of components in isolation, and therefore, as long as P and Q can interact, we need to test them together. So, the interpretation of this axiom for object oriented programs is that we cannot consider methods as units. Just testing methods and then integrating them may not be correct. We need to test the classes at the unit level and integrate the classes. So, that is the first important result, that class is the basic unit of testing for object oriented programs. Now, let us look at some of the object oriented features, important features, and let us see whether they help in testing or they create problems, hinder testing. First, let us look at encapsulation. Encapsulation, as we know, is having the data and the methods together. Actually, encapsulation is not a source of errors, but then it is an obstacle to testing. Why is it? Because due to encapsulation, we cannot directly access the private variables of a class, and therefore, a debugger would become difficult to find the values of private variables of classes, because there are no methods which will report, and for accessing these private variables you need to access it through methods, you cannot directly access it, and therefore, it becomes complicated. So, how does one overcome this problem? Several solutions are possible. One is state reporting methods. So, we might have additional methods in a class which report the values of these private variables. Low level probes to manually inspect object attributes or formal proof of correctness techniques. We do not really look at the variables, but proof of correctness techniques. But the most promising way is the state reporting methods, and normally this is the way encapsulation is handled by the testers. They are state reporting methods, and they overcome the encapsulation problem and can check the values of the private variables. Now, let us look at another important feature of object oriented programs, which is inheritance. Inheritance, we know that one of the important benefit of inheritance is that once a class has been tested, is working well, we can add new features in its subclass, and therefore, we reuse working code. We do not have to write all that code, it has been tested and written, and we just add few methods or class variables. But then the question here is that once we have a derived class and it inherits many of the methods from the ancestor classes, should the inherited methods be tested in the derived class? Surprisingly and unfortunately, it is mandatory to test the inherited methods. Retesting of the inherited methods is the rule rather than an exception. Why is that? Because these were the methods that were all tested in the base class to be working fine, and we have just inherited them in the derived class. Why do we have to test them again thoroughly in the derived class? Let us examine that problem. So, this is a base class library member, and we have derived classes and several hierarchies of derivation, and the methods attributes here become available in students, and then the students adds further attributes and methods. So, all that is inherited by these children classes and so on. Actually, retesting is necessary because of the new context of use in the subclass. So, that is basically the anti-composition axiom again. We will see this with some examples, what do we mean by new context of uses. But then we can say that if we observe that a method has behaved correctly at an upper level, does not guarantee that it will behave correctly at a lower level. Let us look at some examples. Let us assume that this was the code here. Class A had this variable x having value 200, and the invariant or the requirement on this variable is that x should always be greater than 100. And then we had several methods here which were using this variable, and they were all maintaining this invariant. That is the way the class was designed, and they were working correctly. But then some programmer extended the class A, and he did not really look into the code, just extended it, and here he introduced the additional method that he needed M1, where he set the variable x to 1. Now, once he has extended A into B, the methods which are inherited here M etcetera, which are working earlier, will fail to work, because the invariant has been violated here. So, this is one simple example. Let us look at another example. A class A had a method M, which was in its body calling another method M2, and M2 was also defined in class A. So, both M and M2 are defined in class A, and M2 is called by M. Now, class B extends A. but then it has overridden method B. Now, when M is called in class context of class B, then M is inherited here and we call M was working all right in class A, it was tested. Now, for a class B object, when we call M, it is called in the context of class B, and therefore, due to polymorphism, the call M will now call B dot M2 rather than calling A dot M2, and therefore, it was working well with M2, but now the same M is calling B dot M2 and therefore, it may fail. And of course, when we have method overriding, we have written a new method overriding a base class method, obviously, we need to test. So, the inherited methods we need to test and also the overridden methods we need to test. So, the original hope that methods have been tested at base class will not have to be tested in the derived class is not true. We have to test actually all those methods which have been inherited from base class. So, we are just running out of time in this session. We will continue discussing about how to test an object oriented program in the next session. Thank you.